Good morning and good afternoon, scholars. Welcome back to geometry class. This is our last official week of geometry. Today, what I'd like to do is go over some information with you regarding your upcoming final. First off, what I'd like to say though is that I've had a fantastic time this school year spending with all of you and seeing many of you blossom into the young adults that you are quickly becoming. I wish at this point in the year we could be in our class hanging out, pizza parties and things like that, and having debates over mathematical terms and little races and the quizzes activities and stuff like that. But here we are. For your final exam, the way that it's going to be configured is somewhat similar to our midterm, where it's going to be posted on Edulastic, and you'll have or be required to upload your work to Google Classroom again, but it's going to be a little bit different. The way that I essentially have it structured is I'm more looking to see how well you're conceptualizing the material versus just being concrete and producing like a numbered based answer. With geometry, as like a mathematical field, it's very, very, very useful in terms of real world environment. Like we can take a lot of these ideas and position them into like designing your living room, constructing bookshelves or hanging bicycles on the wall and things like that. We can use this terminology to kind of like use real world examples in many ways. And in your exam, there's certainly going to be algebraic questions and things like that, like solving for missing angles. But there's also a decent portion of the exam is going to be like vocabulary. And I just want you to either be writing your own definitions for certain words or using multiple choice, wink, wink, for some of these terms. So what I'd like to do right now is kind of show you what study guides and what kind of material I've created for you to help you study for this particular exam. So let's take a look. Here, this may look somewhat familiar. I decided to take a similar avenue in terms of sharing information with you like your midterm, because I found that this way of breaking down kind of the content for you was very useful. I got a lot of great feedback from you. And it's also kind of like how I do it myself as well too. To kind of show you what's going on here, this exam here is going to cover material from the end of T2 till the end of the school year, but really it's kind of like everything. It's anything could be applied, and as we know with geometry, all this stuff that we did in September and October is still relevant today, like equations of lines allow you to find different portions of, say, rectangles or triangles or circles, things like that. The way that I have this sheet broken down for you, I think is very useful. The first section here is going to be kind of what vocabulary is going to be on your exam. So hint, 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 take a look at this stuff. My suggestion would be for you is as you're going through this study guide would be to find a word, say like cylinder or prism or pyramid or cone. Just tab into it, say cone, and then put your definition in here. The reason why I have your study guide formatted this way, this is how I studied in university. So I just tried to toss in as many words as I can, and then I went through and defined everything. But I wanted to break everything down for you in a nice fashion. So take a look at these terms here, memorize them. As a suggestion would be to define all of them because there's going to be something similar on your exam, but it's also useful to be able to articulate these kind of terms here, like what is perimeter, what is the Pythagorean theorem, like actually writing out the equation, say a squared plus b squared equals c squared, and it's useful in right triangles. Going further down the page is when we go into kind of like what theoretically could be used in terms of like solving mathematically an equation, like if you're presented like a word problem, what type of methodology you're going to use. Similar to in previous instances, what I did here was broke down the various sections that are going to be covered on the exam, and then I attached YouTube links associated with everything. Like so for instance here, if we go down to vocabulary for circles, we click on link number 5 and we launch that out. What we're going to be able to see here is our circle section covering vocabulary. So pretty straightforward in that sense. As we go down the page here, some other things as well too, seeing more and more examples, more detailed examples of different things. We go down to page 3, 4, and 5. What we have set up here are basically just the equations written down for you, and I gave you some like key and some extra pieces of information. Like for instance here, when we're talking about the equation of a circle in standard form, this equation right here, as remember, if we're going to be inserting our h and k values, that the positive values of say 5 and 3, when they get inserted into the equation, because of that minus sign, get visually represented as say x minus 5 and y minus 3, but we know that if we inserted a positive value into the equation, they'll look like a subtraction sign. So little key-ins right there. Our volume equations written here, just shortcuts for information like base times height for our cylinders because we have constant cross sections. Cones and pyramids have that proportionality of 1/3, and our spheres have that unique equation of 4/3 times pi times the radius cubed. Don't forget, radius cubed. Down here we have our line equations, things to remember as well. As always, you're going to constantly see this, and in math next year as well too, when we have things like parallel slopes are congruent, aka parallel slope of 1/5. The parallel version in another line is going to be 1/5. We're talking about perpendicular slopes. We're talking about literally going one direction and doing the exact opposite thing, which is a 90-degree turn. Perpendicular we call opposite reciprocal slopes. So a perpendicular slope to 1/5 would be -5/1. As we continue down here, we have things like midpoint formula, and we have some charts pulled directly from our notes packet. As a reminder, if you do not have some of your old note packets, which makes sense because we still unfortunately can't get into our lockers, you can go on to Jupyter in the materials section, you can find different files labeled like Unit 4 notes, Unit 5 notes, Unit 6, so on and so forth. Right when everything started in our school clothes, I snuck inside and scanned in everything for us. So there's a ton of stuff there. As we go down, we have our special parallelograms chart, definitely on your exam. That's why it's here. Transformations, definitely on your exam. That's why it's here. Wink, wink, wink. Rotation about the origin, or rotation about a point. So this is the breakdown, say like an outline form of a study guide. This is where I would recommend for you to like go through, find words, and try and define these things in your own. Try and comprehend them in your own particular verbiage. The more repetition you have with exploring these concepts, say like heartbeat and boomerang method here in the center, one thing that you can write about heartbeat and boomerang is allows you to solve for missing sides of triangles when we have these like comparative or related triangles. That's when we can do those statements equivalent to one another. The next thing I want to show you here as well too, this would be essentially your assignment for today. This is going to be due on Thursday. What I would like for you to do is answer at least 2 questions per page. Some pages only have 2 questions, so answer everything on the page. But I gave kind of examples and definitions and explanations on how to do a lot of this stuff in this particular second file. Our T3 final review. It's going to be a little bit similar to our midterm one. Examples here, like for instance on this page when we're talking about special parallelograms and things like that, rules that we can use. I went ahead and described some of the logic when I see a question like this, how would I go ahead and answer it. What I'd like for you to do once again is for each page just answer 2 questions, and that'll be due Thursday. I went through, grabbed like Regents examples of questions that you can use and ones from our notes packets that we've done before. The first few pages are going to be newer examples, like for geometric mean, different little practice questions that you have here. Gave an explanation of how these methods work. I linked a video for you as well too, so you can go in and find it. It's very, very, very nice notes packet. Here we're talking about transformations. This was not on our previous midterm, so we got a new page of content here with some information pulled directly from our notes packet. This link, number 21, this links out to a different individual's video covering this type of content. I didn't answer it myself. So we go through different volume examples. Once again, answer 2 per page. If I were you, what I would do is go ahead and try and answer as many as I can. Next up, triangle sum theory. This is when we're talking about internal angles of a triangle equal to 180. So for instance, in question number 17, we would do 55 plus 54 plus 74 plus x equals 180 because we're supplementary. If we're talking about, like, say, question number 9, where we're looking at what we would describe as our exterior angle theorem, we can use this notion of linear pairs, like here with 80, to solve for our missing side. But cool thing within triangles is that this exterior angle is equivalent to the 2 non-adjacent angles. So in question 19, we can say 97 plus x equals 64 plus 27. The reason why this exterior angle theorem works 100% of the time is this little portion right here. We can think about being something, say, similar to like a linear pair equivalent to 180. This missing portion here is that same value that would allow us to do 97 plus x plus 27 plus 64 equals 180, because all these concepts are related to that 180 notion. They all sum out to 180. So we can use them reflexively back and forth, which is pretty cool. Lastly, some of the last few pages are based upon our previous notes packet. So if you still have that information down, you can refer to it once again. Just going through attached links, things like that. Midpoint is definitely on the exam, so take a look there. Got your formula here. Sine, cosine, tangent, there's definitely another equation associated with that. If you can remember how to do question number 1 here, you're in very good spot. Our circle equation, as well too, finishes out our packet. What we're going to be doing on Thursday, what you will see is a video posted up to YouTube again. What that's going to do is I'm going to just select random questions, and I'm going to do it right now, essentially. A video answering a few of these so you can see it worked out. What I would like for you to do today, on Tuesday, during our live classes, come in and we can just talk stuff out. If you have questions, it's going to be a little bit less in terms of like an immaculate lesson. It's more so to set you up to what's going to be on the exam and kind of go through stuff and like key in with questions for you. And then on Thursday, it's going to be a bit more structured in terms of like, I myself, Mr. Sniffen, answered question number 6 on page 4. During the live lesson, I'm going to answer question 5 and 4. So you have a lot of examples of going through this stuff. So remember, your exam is going to be logic-based for the most part. There's about 5 or 6 questions where you're doing the math. There's a bunch of other questions where you're working with the vocabulary or explaining a concept to me using your own words and not Google. So please, please, please go through your packet. Lastly, to finish up with our video here for your exam, once again, it's going to be on Edulastic. Certain questions have algebra with them, and I want you to show your work. There'll be a nice big bold print. All you have to do is attach it to the classroom assignment. For those of you who are pulling definitions and things like that from online sources, just so you know, it's a 0. Don't cheat. It's really, really, really obvious, even in terms of the algebra stuff. I know how I taught you to do certain things, and I know exactly how a computer spits it out. Some of you were given a little bit too much slack on your midterm, and it's not happening on your final. It's really obvious to tell. So please, please, please do it all in your own original fashion. Your exam's going to be only an hour and a half at max amount of time. If you have time and a half or double time, of course, that gets calculated as well too. But it's not a super long exam. It's less than 20 questions. It's mostly your own words, mostly your own explanations. So please, please, please come prepared. All right. If you have questions, as usual, feel free to reach out to me at any time. There's still another extra credit assignment posted up for Delta Math, so you can get that in as well. So I guess until next time, have a nice day, stay safe, wear your mask if you go outside and protest. Bye.